All right, let's take a look at it. And what I mean by looking at it, look what happens. Is it really alternating? And somebody says, well, why do you do that? I wouldn't be assured that anything's alternating unless I looked at it. So I'm going to look at it. So what do I get? The bottoms are easy, by the way. It's ln, fourth power of 2. And if you did the cosine of 2 pi, you get 1. What's the next term going to be? Let's take a look at that. That's going to be, let's see, you're going to do 3 now, right? So let me just think about that. 1, 2, oh, that's minus now. I'll put this over here. 1 over ln, fourth power of 3. Then you go to 4. We're back to positive. And I think at this point, I'm convinced it's an alternating series. All right, convinced of it. It goes plus, minus, plus, minus. So I can get my eraser out, and I'm going to write it with that cosine, because that caused me to pause for a second. What do you get over here? The sum, n equals 2 to infinity. I prefer to use minus 1 to get alternating n. All right, and that's going to bring it back from plus, minus forever. And then ln, fourth power, n. All right. All right, so I know it's an alternating series, and let me just, I guess the first thing I probably should do is just use the AST a minute. And I'm going to write AN down for you. And what's AN? AN is going to be 1 over the fourth power of the natural log of n. And I'm pretty much convinced, I should write it down, by the way. N goes to infinity, AN goes to 0. Whoops, didn't mean to put that down. And I'm pretty much convinced let me write this over here, that this is the case. It's decreasing. So I'm going to say it definitely is conditionally convergent. That's a definite fact, by the way. All right, but the question now is, it's not easy, and I realize that. It's going over this, absolute convergence that is over here. So what I want to do is I want to encourage you to start to read what I write down. All right. So I'm going to say we got this part covered. That was pretty easy to deal with this. We did the AST. I'm going to say that was fairly easy to do it. Right. And I did say that converges conditionally at that point. All right. So the question is, can you go further than that? So it says over here, not easy to show, but you might want to check out a computer algebra system, Sage or Mathematica, see what happens. All right. Now, someone says, what do you mean by that? This is the absolute value of that series. Check it out. Go to Sage, or if you have Mathematica or Wolfram Alpha, and check it out, right? See if you can do it, right? What else could you be doing over here? Maybe, I don't know, trying something that you know from the past, by the way, all right? So something from the past. Thank you. By the way, there's a positive term series. Positive term series. Thank you.